All right. So this is a very live demonstration on mobile hotspot with 256 kilobits per second. So this is very much about speed and performance and prayer. So at several points, I'm going to ask everybody to raise their hands and pray with me that everything goes well. Okay. All right. So yeah, a little bit about me. I used to work at NASA Ames in Mountain View, California. Before that, I worked at Ansible and CloudBees, and so I've been working in the open source space for a while. Love it. Love being paid to do it. It's fantastic when that can, you can put the two together. But for myself, I am really passionate about performance, and so it's kind of led me into some really weird ways in web performance. I'd say just generally, most people care about performance at the first load, and they don't really care about what happens after that. The internet's optimized to sell underwear and socks, not really to write and run mission critical software like mission control software at NASA. So I actually just recently joined CrowdStrike in January. So after I accepted this talk and had everything queued up. And it's an awesome organization. I get to take everything I've learned over the last 15 years with me. And I'm super excited to kind of share kind of the stuff that I had learned over the last 4 years and kind of where that led me. So I'm also a Playwright ambassador. I don't know if anybody has any animosity there, but I am here, not on behalf of them. And I'm also a K6 champion, so working with Senor Performa, who was just up here. But yeah, so let me start off by talking about the application that we're going to be testing today. It's called OpenMCT, and I said it's open source. And where do we go when something's open source? GitHub. Oh, no, we don't. Okay. Now you get to watch it load. Okay, there we go. Yeah, so all of this is open source. Everything that I'm going to show today is out there. It's available. A little bit of history behind this. So I think in mission control, there's a lot of thick clients out there. There's a lot of history out there. And so what OpenMCT set up to do was basically, and again, I'm no longer with the project directly, but I still contribute, focus on basically creating a universal platform for people to share displays of telemetry data and do that in a way that no other piece of software can, as performant as possible. And any F1 fans in here? Anybody? Anybody? So it's open source, right? So the craziest thing happened. One day, we were just, looking at our GitHub discussions, and someone came on and shared this video with us, which is, hey, I built this thing. I work for the Oracle Formula One racing team with Max Verstappen, and here he is using OpenMCT. I swear to God, I didn't look right there. You see him? Isn't that cool? Yeah. So just open source. I forget what they contributed. I think they were contributing something with mobile. But yeah, so Max Verstappen in the Oracle Formula One racing team use OpenMCT for instantaneous telemetry feedback while he's doing his sims. I understand he's just as good in the sim as he is on the track. Can anybody vouch for that? I'm not a huge fan, but I'll just assume he is. And due to the power of OpenMCT now. But yeah, there he is. So you can see right there, you can see how he's using it, right? Gauges, displays, telemetry, really pushing the boundaries of what the web can do, but more specifically what the browser can do, right? The browser is a very limited platform. So in this talk, we're going to hone in on one very specific area, just because we only have 45 minutes and 46 seconds left. So we're going to talk about network. We're going to talk about why it matters, what you can actually do about it. You're in total control here. Talk about kind of the areas we're going to explore in the future, and then I'll leave a lot of time for Q&A. So let's set the stage. So before I get started, is anybody here a designer, Figma artist? Okay, good, because I'm really bad at design. Okay, here we go. So we got the box of concerns, right? And then we got the box of app concerns, right? So CI and Jenkins are kind of synonymous. you have your tests, you have your test runner, right? PyTest, whatever it is, Chrome. And on the other side, we have your UI, we have your front end, and the back end, right? We'll just call it that. And you need to communicate with it. So we have our side, and there's the other side. And what I'm going to demonstrate today is kind of how they kind of work together to make a more performant CI implementation. So let's break it down a little bit further. Jenkins, I think we see this more than the actual logo at this point. That's disparaging, I'm sorry. But we also have our test runner. And the way that we scale, I think generally now is vertically, right? So you just throw more CPU, you throw more cores at it, and you can do more without changing anything from an architectural level. And then you have Chrome talking to the web app, and they're all talking in kind of a pipeline linear flow. This is important because I'm about to break it up. All right, so let's parallelize the tests, okay? So this is the other way. So you think about vertical, right? You just throw more money at it, and it scales automatically, right? You can do more with the same amount of test run or whatever you got. But to go to the next boundary, you need to start scaling horizontally, effectively. Even though this is vertical, everybody can just tilt your head this way. Again, I'm not good at design. But yeah, you start having Jenkins communicate to your test runner communicating to Chrome in parallel, right? And then back to the UI app, and then in parallel there. That's how you run 3 tests sharded. And I don't like writing or saying the word sharded. It's a very, very dangerous word. Okay. So where you go from here, though, right? So this is, we're going on a journey together. Where we all more or less end up is with pools, right? So you end up with Selenium Grid. You end up with browser stack, all of the great options out there. But you have a pool of resources. You have a pool of test runners that you can tap into. And then you have your UI app. But what you've actually done is something that's a little bit dangerous when we talk about kind of CI performance, which is introducing latency. And so we're going to spend a long time here. So I have an app out there, not an app, I have a repo out there called Turbocharging Selenium, which is like going to be like a demo playground for people to play around with. And all you need to do, git clone, Docker compose up, and then presumably start Toxy, and then start your test. I say presumably because this didn't work at around 11 p.m. last night, so let's see if this works. But yeah, so for today's talk, I'm really going to be using WebDriver IO. Anybody here use WebDriver IO? Yeah, it's awesome. But the thing that I need for it today, what I need for it for this demo, is the ability to switch between BiDi and WebDriver, kind of like on the fly, right? Then I also need chaos, like proper chaos. So there's a tool out there called Toxy Proxy. Raise a hand. Anybody here use it? Know about it? Okay. So what I'm here today to do is basically sell Toxy Proxy. It's open source. It's by, let's see, who makes it? Shopify. Okay. So this is an amazing tool that everybody should be using if you're involved in CI architecture at all, right? If you want to blame the backend at all, if you want to blame your app at all, if you want to blame the SRE team, if you're blaming all these people all at the same time, it might just be you. Like there might need to be an intervention involved, but this is seriously a great tool. And so all you need to do to set this up is they have, let me see if I can break it down, clients, right? So you can be in your test, executing your test in your native tongue, and then start interjecting latency, bring a link down, shape the bandwidth, slow to a close, timeout, reset a peer, slice, do whatever you need to. Basically have total control over the environment. And I'm going to do just 2 things today with that control, using OpenMCT and Docker. So we took a look at it earlier. So let's, again, everybody can put your hands together, please. This didn't work at 11 o'clock last night. Okay. All right. So I'm going to go through OpenMCT really quick, just by hand. Okay. So starting from scratch, we're going to create a dashboard, something that like Max Verstappen would want, right? So we're going to hit the, this is a web app. There's a big, nice blue button here, right? So we're going to click on it, not even know what we're doing. Click on it. Then we're going to select display layout, right? Then we're going to go down to the next big shiny blue button, click OK, and then we're here, right? And so the test is pretty much that simple. So let's go ahead and pull up the test code really quick. Yeah, this is kind of boring, right? You guys all know what you're looking at. All right, let's just skip this. Okay. So that's kind of what we're going to do in OpenMCT. So what I'm going to do now is run the test locally and headed, okay? Your guys' hands went down. You guys have more faith in this than I do. Let's see. Ah, it worked. Okay. Thanks. All right. Okay, so the next thing we're going to do is we're going to add a little bit of chaos. So what I've done, and I'm not going to do it again because this is not truly idempotent, which is what broke everything last night at 11 o'clock. But if I were to want to tempt fate, all I would do was do npm run test or toxi setup. And all it's going to do is just use one of those clients we talked about earlier, and it's going to add a filter, effectively a filter that every piece of network traffic has to go through, depending on who's targeting it. So the first victim here is going to be Selenium. So the first target is going to be test. Let's see, slow, creatively named. I don't work in marketing either. Okay. Uh-oh. Here we go. All right. So earlier, I don't know if you were paying attention, what we were looking at was the debug, right? You can see all the debug kind of pouring out of here. What you'll notice now is just how much slower the test is running. And all I've done is added 500 milliseconds of latency between my computer to my computer to my computer to my computer, right? There's just a little sliver of latency between Selenium and my MacBook. And the test went from whatever, we'll look at it on the next slide, but you can see just how much slower it is to execute, right? Nothing really changed about the architecture, nothing really changed at all. The next test I'm going to do is Selenium Toxi Slow OpenMCT. So in this particular case, I'm going to run OpenMCT with a little bit of latency between it and me. Pretend that OpenMCT is on the internet. You can see it a little bit faster, but so the live demos work to some extent. So let's take a look at what happened. So here's what happened. So we had the Mac, we had WebDriver I/O, we had Selenium, and we had the OpenMCT Docker containers, all pointing at each other. Remember my poor drawings earlier? It kind of maps back to that. We added chaos. We have a test runtime and a runtime percentage over the baseline. So the first thing you saw was Chrome driver. The next thing we're looking at is injecting basically a little bit of latency in front of Selenium. Then we have the BiDi and WebDriver protocol here, right? So you can see in the first example, between my Mac and WebDriver, I added 500 milliseconds. In the second example, between my Mac, WebDriver, and Selenium, in a container, I added 500 milliseconds, BiDi and WebDriver. And then in this last example, we have an app gap, which is basically Mac, WebDriver, Selenium, OpenMCT, right? So the baseline, if you were going to run everything locally, right, everything purely locally is 4 seconds. The second you add just a little bit of latency to any single component here, the runtime explodes by 175%. This means every single timeout you have configured in your entire application needs to be adjusted by 75%. That's the significant thing. All we did was add latency in one place. When we add it in two places, right, it goes to 21 seconds. So you have to increase your timeouts by 425%. That's the difference between running something locally and running it in CI, and CI just being this very expensive MacBook, right? That's all this is. And with BiDi, it comes down a little bit. And this is something we're going to talk about at the end. This is some point of investigation. But interestingly, if you move the app away from my computer, right, logically, by just adding that same exact amount of latency, it only doubles, right? It only doubles. And you would think that the further the app gets away from this computer, the slower everything would be, but that's simply not the case. So in summary, in order to scale, we need to add the network. And network is really bad for UI testing performance. And there's not enough time for this in today's thing, but timeouts really start to cause flakiness. You saw at 400%, 475%, your timeouts all have to be adjusted, and that's where things start to go wrong really fast. So I said I used to work at Red Hat. One of the things we did was basically build an in-house Selenium grid. And what we saw was 27 hours of execution time down to 9, which if you think about culturally what that does, right, that's a day, right? 27 hours is not a day. That's somebody else's problem. That's tomorrow's problem, right? And so what you can do once you really start shaping your CI to get things down, we still used Browser Stack, and Browser Stack's great, and it has a lot of utility beyond just parallel grid execution. But the big thing was Flake. So the biggest thing that we found was Flake kind of went away, and then all this sudden people actually started paying attention to the tests again, which was something I didn't expect to see, right, when we started getting started, or when we got started. So we talked about what we can do, so we need to talk about what we can do about this, right? So let's say you don't have the power to just completely reshape your entire organization. There's a few things we can do. Architecturally, we can do some simple things, and we can write certain tests a little bit differently, and we can question more things about our fundamental architecture. So the big thing is, remember bad drawing earlier? Anybody remember what this was, horizontal or vertical? Horizontal, yeah, okay. Even though it's vertical, shift your head like a dog. There we go. All right, so what you can do is co-locate. So what I demonstrated in the test earlier is once you co-locate all of your work, it doesn't really matter, right, where Jenkins is, as long as your test runner, your Chrome browser, and your UI app are close together, right? It doesn't really matter what you're doing. So if you can co-locate all of the UI testing that you're doing in your organization to get it as close as you can to your app, front end or back end. And if you can't, squish something together, right? Just get as many things together as you can. Every millisecond counts. And then this is something that came up several times at every organization I've worked at over the last 10 years. There's like this fundamental law of computer science, which is every QA team over a long enough timeline will rewrite their SDKs in Python. I don't know if this is true in your organization, but over a long enough timeline, they will make this very beautiful way of interacting with your application that serves the tests. And I was very fortunate, actually, at Ansible that we took that and just sold it. It's called AWX Kit. We just literally took it, and then marketing started selling it. That's the only example I know of where the QA has actually made a product that can be sold. But the reason is that over a long enough timeline, all UI tests eventually just find a way to interact with the APIs or the services themselves to speed execution up. And so you can write your tests a little bit differently to do things in the API first, and then do things to directly navigate around. So the biggest problem in the test that I showed was the amount of clicking that was happening and the amount of waiting that comes while you're waiting for all these clicks to come through. So you really want to focus on directly doing what you're doing and getting out as fast as you can. And so the fundamental question you need to be asking when you're doing UI testing, are you testing the UI, or are you just out of convenience testing through it, right? That's the thing that you need to make a decision about in your organization. It's okay to do both, but you need to understand why you're doing what you're doing. And so Senor Performo talked about K6 and synthetic user monitoring. So when talking about JMeter, when you're talking about scaling JMeter Selenium versus JMeter API calls, you have to budget around 1,000 times more CPU and 1,000 times more memory per single session for a UI call versus an API call. And so it really starts to matter how you decide what you're doing within your application. And what I saw when I switched my previous team and organization from doing most of our interaction through the API when necessary, is that we got our run times under 5 minutes. So we could execute around 26 hours worth of tests perfectly in parallel, and we could do that only because we were doing as much as we could through the API. So talking about the future, which we didn't have time to cover, is BiDi. So BiDi, I think, is really the power to get out of this. So a lot of the problems with, I think, the traditional WebDriver Classic, is it called Classic? Okay, Classic, it's like Coke, is just that it's kind of stateless by design, and so there's a lot of benefits that we get by using the bidirectional communication, event-driven architecture. The thing I really want to do in the future coming up is show CPU throttling. So a lot of the times when we're scaling vertically, we're doing everything we can to squeak out every little ounce of CPU in a CI system. And then the problem that I'm facing right now, it's not my future, it's my reality. With UI testing properly scaling, eventually you just create a DDoS system. Has anybody else experienced this, where your UI tests eventually take down production and staging? Yeah, it's a real problem. Does anybody's, with a raise of hands, does anybody's here's staging have the same performance capabilities as their production? Or is that just, okay, one guy, he's gonna get beat up in the parking lot on his way out. Yeah, it's just not possible. It financially doesn't make sense either, right? So in summary, we kind of talked about why network matters, right? We talked about why it matters and why it should be looked at. We talked about what you can do about it by co-locating, moving things around. And we talked about future exploration through CPU, BiDi, and finding that guy in the parking lot. And then, and that's it. So that's what I got to share today.
Wait, what? We have 5 minutes just for questions. So just three questions. Who has questions? Nobody? No? Yeah.
Hello. What do you think about mocking and the trade-offs of mocking the network in order to turbocharge your tests?
Yeah, so I was a huge proponent of mocking, but those mocks eventually become more or less a contract that needs to be maintained. And it falls almost squarely into kind of like contract testing. So what I think you should do, or what I would ask everyone to do, is find the person that maintains your SDK, because they're likely generating API interactions in some way. Reach out to them and figure out what they're doing and leverage that instead. So often you can find the guy that's doing that in your organization by whoever maintains the SDKs. That's what I've done twice. But yeah, the mocks themselves become something to maintain. But you get the performance. You get a lot of performance out of it. Is that something you've done with mocks? Yeah. Yeah. Then who's to blame? It's kind of your fault, so you got more work to do.
Another question? No? Okay. Then have a thank you to John.
Thanks for praying.